Okay, in this one we're gonna build on top of the previous video I made about rewriting the ping command in C. And in this one we're gonna attempt to rewrite a basic traceroute command. And so if you've never seen traceroute, this is how it works. You just run it on some domain name or IP, and it gives you all of the hops that it goes through to reach that destination. So here we can see that first it goes to my Fritzbox, so yeah, my router, and then it goes probably to some ISP stuff, and then it goes over, I assume, a lot of reverse proxies to end up with the Google IP. So yeah, I mean, Google is maybe a bad example because they have a ton of weird domain names, but this is Google, trust me. And so yeah, we're gonna try to rewrite this and explain how it works under the hood, this command. So I've abstracted a tiny bit the previous videos. So I have this main where I have ICMP create socket, and then I can close the socket. And basically the only thing I did is that I have a little ICMP module where I have a create socket, a send and a receive method. And this is a hint of how it works. We are going to have a TTL on our packets. And so in the ICMP thing, there is nothing new if you were in the last video. So there is a thing to get the checksum of a packet. We store the destination and the source IP address, and yeah. There is a little helper function to convert a domain name to an address info. There is another little helper function to convert an address info to an IP. It's just to print stuff. And then here is the ICMP create socket function, where yeah, I get the address of the destination domain name. I just print it. I create a socket, same way as before. So it's a sock diagram with the ICMP protocol. And here in the send, I build a little ICMP packet, and then I compute the checksum on it, and I send it to our destination. In the receive, I just call receive from, and the received packet will be in packet, and it will also put the address of the thing that sent it to me in source address. So this guy. So anyway, let's modify it a tiny bit so that we can actually use traceroute for this. And so the way traceroute works is that it sends ICMP packets with increasing TTLs on them. So a TTL of a packet is just a number that says if this number goes to 0, just stop trying to go further in the chain of hops. So if you have 32 hops between you and Google and you set the TTL to 16, it will go to the 16th place, and then the TTL will reach 0 here, and then it will send back something to you, or it will time out. And so yeah, and the TTL gets decremented on each hops. So yeah, that's how it works. Initially, it was the TTL was created, I think, to avoid like a network infinite loop, where yeah, your packet would just run in circles. And since they introduced this TTL, if you would run into a circle, you would eventually end up with a TTL of 0, and so it would cancel out this packet. So anyway, but we can play on this with traceroute to yeah, to set a TTL of 1, and then we will get the first IP address in the first hop, the TTL to 2, and then we will get the second hop, the TTL to 3, and then we will get the third hop, and so on and so on and so on, until you reach the destination. So let me quickly implement the way of setting a TTL on an ICMP packet, and I'll get back to you after. Okay, it's done. So the first thing we have to do is to add the IP header to our packet. So right now we let the Linux kernel handle all the IP protocol stuff, but since we want to set the TTL, and the TTL is on the IP level, we need to create our own IP packet, or well, IP header, and then put the ICMP header right after it. So in the IP header, you always need a source and a destination. So we're gonna get the source of our own machine, with get host name, and then we're going to use this little function that I used before to get the address of it. And then I have a source IP address variable, which is just a static global here, which we'll use later. We need to change the socket to be a raw socket. Raw socket just means that I'm going to create the IP. I'm going to handle all the IP stuff myself. And we also need to have this header include socket option to say that we're also ourselves gonna include the IP header. Otherwise, the OS tries to include it itself. The very big downside of using sock raw is that now only root can use this socket, so we will need to run our program as root. I know there is other ways of doing it with sock dgram still, but it was a bit too complicated for this video, and so I'd rather just use this because it's slightly simpler and it also is easier to explain. So our ping structure, I just added the IP header structure in there before the ICMP one, of course. And here, this is what we had before. So the regular ICMP echo packet. But I've added the IP header there. There is a lot of boilerplate, but the main thing you need to focus on is that we set the TTL here. So the TTL which will come from the main. And we set the total length to the IP header plus the ICMP header. And we set the source and the destination addresses. We also need to compute the checksum. It's the exact same computation as the ICMP packet. And then we send both. So yeah, now let me do the rest of the stuff to be able to actually send those and in the main, and I'll show you after. So in the main, we're just going to do a little loop where we're going to loop over a range of TTLs. I picked arbitrarily maximum TTL of 32, and then we're going to set each of our packets with an increasing TTL and send it each time, and we should receive either a timeout or we received a like TTL expired thing, which will also return us the IP address on which it failed. So yeah, here I'm sending an ICMP packet with the TTL that we currently have in the loop, and here I'm gonna try to receive an answer, and I'm gonna store the point at which the TTL expired in source address. So to have a timeout on our socket, we need to set the receive timeout option. Here I just set it to 2 seconds because it's easy and it makes sense. Actually, maybe I can put it to 1 second because otherwise it's a bit too slow. But this is how you set a timeout on a socket, and then what will happen in the ICMP receive is that if it receives -1, it's that it timed out. So yeah, let's play on that in the main and see if we receive an answer or not. Okay, so I just modified the main so that when it returns -1 ICMP receive, that means that there's a timeout, so I print the timeout, otherwise I print that we received something. And as you can see now that I run the thing, we see that sometimes we receive something, sometimes we time out, and now the only thing that's left to do is to print what we received when we received something. So let's do that. Okay, so I just slightly modified the printf, and I'm using getNameInfo. GetNameInfo is basically a reverse DNS lookup, I guess. So you give it an IP address, and it gives you the domain name that is attached to it. And so I just print this and also the IP that was stored in src address in ICMP receive. And now that I run it, we can see that it's very close to what we got on the original traceroute, where I get the domain name, I get the IP for all of those. Like so, maybe the timeout is a bit too much. And we see that we have an issue that it doesn't stop after. So let's make it that when we reach the destination, it stops the program. Okay, so all I've had to do for this is to check the packet that we receive, its type. If it's ICMP echo reply, we will just return -2 as a code. And then in the main, if the return type is -2, we will break the loop. And so we can see now that if we wait a tiny bit for all the timeouts to time out, now it actually stops at this function. And I think that's about it. that's all of the implementation for you. I will put that on GitHub. Should be available. And yeah, maybe a little detail is that when the TTL is exceeded, it returns to you a packet of type ICMP time exceeded. And you can check on that. I mean, there is a lot of different ICMP types, but this is the one when TTL expires. Yeah, so that's mainly it. As a bit of an extra, maybe, if you go explore the traceroute command, you can see that it's much more complex than what I did. I mean, there is some stuff that you could already implement with my little implementation, for example, the max TTL, the queue, so you can have a number of retry for each TTL. By default, the traceroute has 3 retries. You can set the timeout and so on. But more importantly and interestingly, what you can do is that the ICMP method that I showed you is a bit outdated, and nowadays they apparently use, I think they use UDP by default, if I'm not, yeah, so they have this concept of probe packets, which can be, I don't know, it can be anything. It can be the ICMP echo I just showed you in this example. It can also be TCP SYN, for example, like so. And I think by default it's UDP with a very weird port, like 31,000 something. And so they're betting on the fact that this port isn't listened onto, and so that it will just, I don't know, cancel the request. To be honest, I didn't dive too much into this, but I know that that's how it's done by default. And so yeah, it's interesting to see that yeah, you can forge these kinds of different packet probes, which I'm sure can be even more than TCP, UDP, or ICMP. And then just by having some kind of TTL in your protocol, you can implement a traceroute with that. And I think the advantage of UDP and the TCP methods is that they can go maybe through firewalls better, or I don't know, I guess it depends on the situation and the network that you're trying to diagnose, but anyway, it's just good to know. So anyway, I hope you like this video, and yeah, if you want more stuff like that, I have one more idea, which is implementing a basic nmap command. If you don't know, nmap is just to get the ports of a server, like the open and closed ports, and I thought we could maybe, yeah, try to rewrite that so we can see the open ports here. So yeah, let me know if that's interesting, or maybe give me ideas on some other, I don't know, classic commands that you would like to see a basic rewrite of in C. And yeah, let me know, and see you.